So welcome. This is a video based on variable acceleration, in which if we have displacement and we find the derivative of displacement, it becomes velocity. And if we find the derivative of velocity, it becomes acceleration. Then we want to get it back. Then the acceleration integration gives you the velocity, and velocity's integration will give you the displacement. Coming to the first question, the acceleration is given, which is dv upon dt, which is 4t minus 8. And his velocity is 6 meters at t equals to 0. So what am I going to do? I'm going to do the integration. So integral of dv equals to integral of 4t minus 8 dt. So this gives you velocity equals to 4t square upon 2 minus 8t plus c. So we need to find the value of c. For that, it has been given that velocity equals to 6 when t equals to 0. C equals to 4 upon 2 times 0 square minus 8 times 0 plus c, which gives me c value as 6. So what is the velocity value now? 2t square minus 8t plus 6. The distance traveled between the 2 points when it is instantaneously at rest. Whenever it is at rest, instantaneously at rest means velocity should be equals to 0. 2t square minus 8t plus 6 equals to 0. Divide by 2, t square minus 4t plus 3 equals to 0. So it becomes t minus 3 times t minus 1 equals to 0. So t equals to 3, t equals to 1. Now find the integral. Integral of ds equals to integral of 2t square minus 8t plus 6 dt from 1 to 3. So it becomes distance equals to 2t cubed by 3 minus 8t squared by 2 plus 6t from 1 to 3. Plug in the upper limit, 2 upon 3, 3 cube, minus 4 times 3 square, plus 6 times 3, minus 2 upon 3, 1 cube, minus 4 times 1 square, plus 6 times 1. Simplify that. Directly I am writing the answer, 8 upon 3 meters. Coming to question number 2, the velocity of the particle is given. So velocity equals to ds upon dt equals to 6t minus 2. Find an expression for displacement, means integral. So integral of ds equals to integral of 6t minus 2 dt. So s equals to 6t square upon 2 minus 2t plus c. Now he has been given that displacement is 75 when 5 seconds. So t equals to 5, s equals to 75. So 75 equals to 3 times 5 square minus 2 times 5 plus c. This gives me the value of c as 10. So distance equals to nothing but how much? 3t square minus 2t plus 10. Find a displacement after 10 seconds. So just plug in 10. So 3 times 10 square minus 2 times 10 plus 10. Simplify that, you should be able to get 290 meters. Coming to question number 3, a particle P moves in a straight line. Between 0 to 3 seconds, different equation, and greater than 3 seconds, different equation. So you need to take care of that. At t equal to 0, P is at rest, means velocity equals to 0. So t equals to 3 and t equals to 6. So t equals to 3 means we are going to use the first equation. T equal to 6, I am going to use the second equation. So for part A, first equation, A equals to dv upon dt, which is 4t minus t square. So I want the velocity, so integral. Integral of dv equals to integral of 4t minus t square dt. So velocity equals to 4t square upon 2 minus 1 upon 3t square t cube plus c. Now it is been velocity equals to 0, t equals to 0. So 0 equals to 2t square or 0 square minus 1 upon 3 0 cube plus c, which gives me c equals to 0. So what is the equation for velocity? 2t square minus 1 upon 3 t cube. Now I want at t equals to 3. So plug in 2 times 3 square minus 1 upon 3 3 cube. So which is 9 meters per second. Now for t equals to 6. So we have to use the second equation. Second equation is acceleration is 27 upon t square, which is 27 t power negative 2. So integral of dv equals to integral of 27 t power negative 2 dt, which becomes 27 t power negative 1 upon negative 1 plus c. Now just now in part 1 we have learned that v equals to 9 when t equals to 3. So 9 equals to minus 27 upon 3 plus c. This gives me the value of c as 18. So velocity equation will be minus 27 upon t plus 18. But now I want at 6 seconds. So minus 27 upon 6 plus 18. Simplify that, you should be able to get 13.5 meters per second. Question number 4. Again, two equations for velocity. One is between 0 to 5 and another one is greater than 5. Acceleration as t equals to 4. So we are going to take the first equation. So velocity is 7t minus t square. I want acceleration. So differentiate on both sides. Velocity becomes acceleration, 7 minus 2t. Plug in t equals to 4. So acceleration will become 7 minus 2 times 4, which is negative 1 meter per second square. For part B, total distance traveled in the first 10 seconds. So we know velocity is ds upon dt, which is nothing but what? 7t minus t square. I do the integral. So it becomes distance equals to 7t square upon 2 minus t cube upon 3 plus c. Now this equation I should be using only for the first 5 seconds. So therefore I have to find it out the distance between first 5 seconds. So I will apply the limits 0 to 5. 0 to 5. So in that case, when I'm applying the limits, no need to write c. So plug in 0 to 5. So when I plug in 5, it becomes 7 upon 2 times 5 square minus 5 cube upon 3 minus 7 upon 2 times 0 square minus 0 cube upon 3. Simplify that, 275 upon 6. Now for 5 to 10 seconds, we have to use different equation, 10 minus 2t. So velocity equals to 10 minus 2t. So integral of ds equals to integral of 10 minus 2t dt. So which becomes 10t minus 2t square upon 2. Now what am I going to do that? I am going to, what is this? Plus c. I write it out plus c to make it much more easier. We know that at t equals to 5, distance equals to 0. So for example, at t equals to 5, distance equals to 0. So 0 equals to 10 times 5 minus 5 square plus c. This gives me the value of c as negative 25. So s equals to, what is the equation now? 10t minus t square minus 25. Now I want for 10 seconds. So plug in 10, s equals to 10 times 10 minus 10 square minus 25. That gives me negative 25. So what is this negative 25 indicates? It has traveled 25 meters have been traveled. Traveled between 5 and 10 seconds. So total distance will be 275 upon 6 plus 25, which is going to be nothing but how much? 425 upon 6 meters. That's going to be the answer. Now question number 5. The velocity of the particle is given acceleration. Velocity is 6t minus 2t square. I want acceleration means differentiate with respect to time. So acceleration equals to 6 minus 4t. When the acceleration is 0, so 6 minus 4t should be equals to 0. This gives me t equals to 1.5 seconds. Now come to question number 6. A particle P moves on x-axis. The acceleration is given by, acceleration is, which is dv by dt, is given by 6t minus 24. Show that the particle will never travel in the negative x direction. So what am I going to do that? I'm going to do the integration. Velocity integral of dv equals to integral of 60 minus 24 dt. So velocity equals to 60 square upon 2 minus 24t plus c. Now it has also been given that velocity is at the starting point, the velocity is 60, means t equals to 0, v equals to 60. So 60 equals to 6 upon 2 times 0 square, 24 times 0 plus c. This gives me the c value as 60. So what is the velocity equation? 3t square minus 24t plus 60. We have to prove that this never goes negative. So take t common, 3 common, then try to do the completing the square. T square minus 8t plus 16 negative 16 plus 20. So it becomes 3 times t minus 4 whole square plus 4, which is 3 times t minus 4 whole square plus 12. So we know that square term is always positive, 12 is also positive, so therefore this value is always positive. So therefore velocity can be never be negative. Never be negative. Part B. Find the distance traveled in the first 10 seconds. So now we know the velocity equation, which is ds upon dt, which is nothing but how much? 3t square minus 24t plus 60. Now I want the distance, so do the integral. So integral of ds equals to integral of 3t square minus 24t plus 60 dt. So what does that becomes? S equals to 3t cubed by 3 minus 24t squared by 2 plus 60t plus c. As it is starting from rest, t equals to 0, s equal to 0. So 0 equals to 0 cube minus 12 times 0 square plus 60 times 0 plus c, which gives me c value as 0. So what will be s equation now? T cube minus 12t square plus 60t. Now I want at t equals to 10. So plug in 10, 10 cube minus 12 times 10 square plus 60 times 10. Simplify that, you should be able to get 400 meters. Question number 7. Velocity has been given, which is 12 minus 12t square. Distance traveled. Velocity means ds upon dt. So what am I going to do? I am going to do the integration. 12 minus 2t square dt. So distance equals to 12t minus 2 upon 3 t cube plus c. But it is starting from rest. So t equals to 0, s equals to 0. So 0 equals to 12 times 0 minus 2 upon 3 times 0 cube plus c, which gives you c value 0. So what is the equation of s? 12t minus 2 upon 3 t cube. What is he asking? Distance traveled in the first second. So just plug in 1. 12 times 1 minus 2 upon 3 times 1 cube, which is 34 upon 3 meters. Coming to part B, the value of t when p changes its direction of motion. When does it changes? If at all it changes motion, changes the direction, the velocity has to become 0, then only it can change its direction. So we shall check when the velocity should become 0. What is velocity? 12 minus 2t square. 12 minus 2t square should become 0. So 2t square equals to 12, t square equals to 6, t equals to square root of 6. Then the value of t at the instant p returns to the starting point. It has to return to the starting point. What does it mean, returns to starting point? Returns to starting point. Returns to starting point means nothing but what? S should be equals to 0. So 12t minus 2 upon 3t cube should be equals to 0. Take t common, 12 minus 2 upon 3t square should be equals to 0. So either t equals to 0, that is at the starting point, or 12 minus 2 upon 3t square equals to 0. So 12 equals to 2 upon 3t square, which gives me t square equals to 18, t equals to square root of 18, which is 3 root 2 seconds. That's the answer. Question number 8. Distance has been given. What is the initial velocity of p? So in order to find the velocity, find the derivative with respect to time. So which becomes 3t square minus 30t plus 62. Initial velocity means t should be equals to 0. 3 times 2 0 square minus 30 times 0 plus 62. So what is that answer? 62 meters per second. The value of t for which it has 0 acceleration. So just now we got the velocity as 3t square minus 30t plus 62. Find the derivative of that one. It becomes the acceleration. So acceleration equals to 60 minus 30. So acceleration should become 0. So 60 minus 30 should be equals to 0. 60 equals to 30. T equals to 5 seconds. Next, question number 9. A particle P travels on a straight line so that after the time t seconds, the distance formula is given as 2t cube minus 18t square plus 48t. Instantaneously at rest means velocity should be equals to 0. Find the derivative with respect to time. 60 square minus 36t plus 48. That should be equals to 0. 60 square minus 36t plus 48 equals to 0. Divide by 6. It becomes t square minus 6t plus 8 equals to 0. So factorize it out. T minus 2 times t minus 4 equals to 0. So t equals to 4 or t equals to 2. The total distance traveled in the first 5 seconds. So now you have to remember that at 2 it becomes 0, at 4 also it comes to 0. So velocity has become 0. So we have to divide into 2 parts or 3 parts basically. At t equals to 0, distance equals to 0. Now at t equals to 2, find the distance because it is coming to rest, right? So 2 times 2 cube minus 18 times 2 square plus 48 times 2, which is 40. Now again it comes rest at 4 seconds. So find the distance traveled in that 4 seconds. 4 cube minus 18 times 4 square, 48 times 4, which is 32. Now again distance traveled in 5 seconds. So substitute 5, 2 times 5 cube minus 18 times 5 square plus 48 times 5, which is 40. So what is happening? From 0 to 2 seconds, it is traveling 40. From 2 to 4 seconds, what is happening? It is traveling only 8 meters because it is stopping and coming back. So 8 meters. Again, it is stopping and going again further, another 8 meters because 40 minus 32 is 8. So the total distance will be 40 plus 8, which is 56. This should be the way of doing it out. Because 0 to 2, it has went in one direction, stopped and changes the direction, 8. Then again at 4 seconds it stops and again changes the direction for one more second. So another 8 meters. So total is 40 plus 8, which is 56 meters. Question number 10. The acceleration is given, which is dv upon dt, which is 3t plus 5. Then when t equals to 0, velocity is 2 in positive x direction. When t equals to t, the velocity is 6 in positive x direction. Find the value of t. So when acceleration is given and we want to find the velocity, we have to do the integral. So integral of dv equals to integral of 3t plus 5 dt. So velocity equals to 3t square upon 2 plus 5t plus c. Now what is the condition given? T equals to 0, v equals to 2. T equals to 0, v equals to 2. Plug in 2 equals to 0 plus c. So which will give you c value as 2. So v equal to 3t square upon 2 plus 5t plus 2. Now what is the condition given? The condition given is when v equals to 6, t equals to capital T. So 6 equals to 3 upon 2 capital T square plus 5t plus 2. So 3 upon 2 t square plus 5t minus 4 equals to 0. Multiply by 2, 3t square plus 10t minus 8 equals to 0. Factorize it out, 3t minus 2 times t plus 4 equals to 0. So t equals to 2 upon 3, t equals to negative 4. So, but time has to be positive number. So therefore t equals to 2 upon 3. That's going to be the answer. Question number 11. The displacement of a particle is given as t square times t plus k. Given that p is at instantaneous rest, velocity equals to 0. So how do I get the velocity? Differentiate with respect to time. So before that, we can do the expansion. Derivative of t cube plus kt square. Easy way to do. So that becomes nothing but what? Velocity equals to 3t square plus 2kt. But at t equals to 4, it is instantaneous at rest. So v equals to 0, t equals to 4. 0 equals to 3 times 4 square plus 2 times 4 times k, which gives me 0 equals to 48 plus 8k, which gives me k equals to negative 6. So what is the equation for v? 3t square minus 12t. Next, find the acceleration when t equals to 10 seconds. So we know velocity is 3t square minus 12t. So when I do the derivative of that one, it becomes the acceleration. So acceleration equals to 6t minus 12. Now I want at 10 seconds times 12 minus 12. So which is 48 meter per second square. Question number 12. The velocity of a particle after t seconds is given. Velocity means is ds upon dt is 6t minus 2t square. T equals to 0, the particle is at origin. Means, what does it mean? T equals to 0, S equals to 0. Find the distance of the particle O when the particle comes to instantaneous rest. So, instantaneous rest means velocity equals to 0. 6t minus 2t square should be equals to 0. Take 2t common, t minus 3 should be equals to 0. So, either t equals to 0 or t equals to 3. Obviously, we know that t equal to 0, it was s equals to 0. So therefore, what am I going to do that? I am going to do the integration to find the distance. So integral of ds is equal to integral of 6t minus 2t square dt. So what does that becomes? S equals to 6t square by 2 minus 2t cube by 3 plus c. Just now in the beginning we know that t equals to 0, s equals to 0. So 0 equals to 3 times 0 square minus 2 upon 3 times 0 cube plus c. So which gives you c equals to 0. So what is s becomes? 3t square minus 2 upon 3 t cube. Now I want at 3 seconds. T equals to 3 seconds. So s equals to 3 times 3 square minus 2 upon 3 times 3 cube, which is 9 meters. So that completes the question. So that completes this video. See you in the next video. Bye.